one of the most critical Spark capacity, which is to save a data set in memory or disk across operations for performance optimization. Sometimes we would like to call actions on the same RDD multiple times. If we do this naively, RDDs and all of the dependencies are recomputed each time an action is called on the RDD. This can be very expensive, especially for some iterative algorithms which would call actions on the same data set many times. If you want to reuse an RDD in multiple actions, you can also ask Spark to persist by calling the persist method on the RDD. When you persist an RDD, the first time it is computed in an action, it will be kept in memory across the nodes. This allows future actions to be much faster, often by more than 10 times. Caching is a critical tool for iterative algorithms and fast interactive use. Let's take a look at the persist example file under the rdd.persist package. Here we have an integer RDD. We persist the RDD using memory storage level. We'll talk more about the storage level later. Then we call reduce on this RDD. At this point, parallelized transformation will be executed to distribute the RDD from the driver program to all the worker threads and calls reduce on this partition. Since this RDD is persisted, so it'll be kept in memory across the worker threads. When we call count on this RDD again, Spark won't parallelize the transformation again. It'll go ahead to do the count action. Each persisted RDD can be stored using a different storage level, allowing you, for example, to persist the data set on disk or persist it in memory. These levels are set by passing a storage level object to persist method. The cache method is a shorthand for using the default storage level, which is memory only. For memory only storage level, RDD is stored as deserialized Java objects in the memory. If the RDD can't be fit into memory, some partitions won't be cached and will be recomputed on the fly each time they're needed. Memory only is the default level. There are some other types of storage level. Memory and disk. This will store RDD as deserialized Java objects in the memory. If the RDD can't be fit into memory, the partitions which can be fit into memory will be stored on disk, and they will be read from disk when they are needed. Memory only SIR, similar to memory only, but it'll store RDD as serialized Java objects in memory. This is more space efficient than deserialized objects, especially when using a fast serializer, but more CPU intensive to read. Memory and disk SIR, similar to memory only SIR, but it will save partitions that can't be fit into memory to disk instead of recomputing them on the fly each time they're needed. Disk only, it will store the RDD partitions only on disk. You might want to ask which storage level we should choose. Spark storage level are meant to provide different trade-offs between memory usage and CPU efficiency. There are some factors we need to consider before selecting the most suitable storage level. If the RDDs can fit comfortably with the default storage level, memory only is the ideal option. This is the most CPU efficient option, allowing operations on the RDDs to run as fast as possible. If not, try using memory only SIR to make the objects much more space efficient, but still reasonably fast to access. Don't save to disk unless the functions that computed your data sets are expensive, or they filter a significant amount of the data. Otherwise, recomputing a partition may be as fast as reading it from disk. What would happen if you attempt to cache too much data to fit in memory? Spark will evict old partitions automatically using a least recently used cache policy. For the memory-only storage level, Spark will recompute these partitions the next time they are needed. For the memory and disk storage level, Spark will write these partitions to disk. In either case, your Spark job won't break even if you ask Spark to cache too much data. But caching unnecessary data can cause Spark to evict useful data and lead to longer recomputation time.